Okay, good evening. Right, so let's continue with system and system and network administration (SNA). Right, so last time we discussed about installing OS. Right, I explained you how to install. Uh, just give me 1 minute. Right, so I explain how to install Linux or Ubuntu in virtual machine also. So I updated your note, add little bit more details about installing OS. Okay, so therefore I'll take about half an hour and again rush through our note because I updated our note with little bit more details. Okay, to make it easier for you guys to understand. Okay, so therefore we'll take about half an hour, just go through it and then move on to the Linux host management activities. Okay. Right. So remember last class we discussed about the boot process and boot loaders, and also we discussed about the system management daemons. So those are the early high priority processes that runs on startup, and also compare different type of boot loaders. And this is super important topic because a lot of questions are from this. Okay, a lot of questions every year. Right. So remember, boot process is a sequence of steps. Collaboration of hardware, firmware, and of course software or the OS. So that is why it's a little bit more complicated. That is where all three uh, work together. So this is the general process. So I think I updated these slides. So first you power on, obviously. So then your firmware take control, right? Firmware take control. It can be either BIOS or UEFI. Older machines BIOS, the newer machines UEFI, which do the power on self-test and initialize the hardware. So then your bootloader take control. Oh, the bootloader is loaded. Then bootloader load the kernel for the OS. Okay. And then of course your OS has some system daemons. Initially those system daemons will be running and then other process will be gradually running. And you will be presented with login prompt if it is command line Linux or the GUI login. So this is the big picture. Power on, BIOS or UEFI take control, call the correct bootloader, and kernel is uploaded, and system daemons are running, and then login. Okay. So this is more detailed, right? Because this is the overview. Power on, load BIOS or UEFI, probe for hardware, that is power on self-test, post. If post is success, select the boot device, okay, which device to boot, and then load the boot loader, correct boot loader, then decide which kernel to boot, if you have multiple or boot options, or if the user has only one, that will be loaded, or user does not select a particular one, maybe the default one will be loaded. So that OS is now loaded with the kernel. And init and systemd processes are started. That is the process ID 1, right? So that is the main daemon, and other startup scripts are running. That means gradually some other processes are running. And also if there are any startup application software, those will also be started. Now we have up and running system with after login. Okay. Right. So remember, step 1 is load your after switch on BIOS or UEFI. Right. BIOS or UEFI. So that is your firmware. Right. So when you press the power on button, the system firmware starts. It does the post, right? Power on self test. It check the critical component like CPU, memory, keyboard, and then it identify the bootable device and load the bootloader. Okay, bootloader. Okay, and this is general steps. But if it is BIOS or UEFI, there are small changes. So this is in general. Remember, your firmware can be BIOS or UEFI. If it is BIOS, that is old approach. Of course, still you do the power on and power on self test. Okay. You can see this is UEFI. Compare those two, power on self test. It's common whether it's BIOS or UEFI. And if it is BIOS, locate and load the master boot record, which is the first 512 bytes of disk. So if it is BIOS, it locate and load the master boot record, which is a specific location in the hard disk. Usually the first 512 bytes of disk, or sort of a first sector. But that is different in UEFI, right? So it looks for the boot entries on non-volatile RAM. So that is a difference. Now, examiner can ask the differences between BIOS and UEFI. BIOS always assume that your boot sector is the first 512 bytes for master boot record. But there's no such requirement for UEFI because UEFI look for the boot entries on non-volatile RAM. So this is not your normal RAM. This is non-volatile RAM. This is not really ROM also. This is like CMOS. Okay, that is why non-volatile because usual RAM is volatile. This is non-volatile. Okay, right. So let's continue with BIOS option. So locate and load the master boot record, and master boot record bootloader executes and load VBR of the active partition, and the VBR bootloader is executed, and then the load OS kernel. So that is BIOS base. Okay. So you can see there are two words, master boot record, VBR, or volume boot record. So that is another possible question for exams. So what is the difference between master boot record and volume boot record? For volume boot record, another word is boot sector. So master boot record kick off the boot process and tell the system where to go next. That means which partition to boot. And volume boot record is in that partition. And volume boot record load the actual OS. Remember, MBR does not load the actual OS. MBR point to the VBR. Where is the volume boot record? And actual OS is loaded by VBR. Okay, so it's a little bit more complicated process when it comes to BIOS base. So the two words MBR, master boot record, which locate you the volume boot record, and volume boot record load the OS. Okay. So this is a comparison between MBR and VBR. So remember, MBR is first sector of the entire disk. So the VBR is the first sector of the partition because MBR identify the partition. And this is the first sector of the partition because this is the one that really load your OS. Okay. So usually those are 512 sizes. Okay. So MBR purpose is contain the partition table and initialize bootable bootloader code. Bootloader code is VBR. So VBR contains the bootloader code for the specific partition. So basically the button is passed from master boot record to VBR. Okay. So this identify the partition, that is MBR, VBR actually load the OS. Okay. Right. If it is UEFI, the first step and second step are the same. Power on self-test. But this time it look for the boot entries in NVRAM, non-volatile RAM. Right? There's nothing called MBR, VBR. Okay. It's straight away look for the boot entries in non-volatile RAM. Right. And then load the relevant boot manager, like grub bolilo. And the bootloader is loaded, and the bootloader load the OS. Okay. So there's no such thing called MBR to VBR, right? In UEFI, it's much simpler approach, faster approach. Okay. So this will locate the EFI system partition on GPT disk. Okay. So this is another important slide, the difference between BIOS and older BIOS and new UEFI. BIOS is traditional approach, UEFI is the modern approach. BIOS configurations are saved in CMOS. UEFI configurations are saved in what is known as non-volatile RAM or NVRAM. So BIOS task is use master boot record and volume boot record. Right. First locate the master boot record and master boot record, locate the volume boot record, and then load OS is loaded. But when you use UEFI, it uses EFI system partition or ESP. EFI system partition rather than MBR VBR, which is located in the global unique identifier partition table or GPT. Global unique identifier partition table, GPT. Okay. So a lot of words, right? And BIOS usually support 4 primary partitions, but UEFI support much more number of 128 primary partitions. And it allows larger disk sizes also. BIOS provide basic security, UEFI provide enhanced security. BIOS slower boot time, UEFI is faster to boot. BIOS is pretty much text-based, but UEFI graphical user interface is available for configurations. Right. So these days, of course, OSs mainly looking for UEFI. Sometimes if UEFI is not there, it doesn't allow you to install the operating system also. Okay. Right. So remember, in both the cases, it at the end it load the bootloader, right? Bootloader, whether it's UEFI or BIOS, right? It need to load the bootloader, and the bootloader is the one that load the OS. Okay. So there are different type of bootloaders like Grub, Lilo, System D boots, and so on. Okay. So the bootloader, what it does is maybe you have dual OS and so on. So it will present the boot menu if configured. That means if you have installed multiple OSs. Otherwise, it will just straight away boot your system if it is only one OS. Okay. So then when the user select the required OS to load, it will load that OS into the memory. Okay. And then gradually transfer the control to the OS. Okay. That is what happens. So therefore, what are the tasks of bootloader? Identify and load the operating system. Okay. So these are the popular bootloaders: grub, bootmgr, lilo. Right? Grand Unified Bootloader, Windows Boot Manager is bootmgr, lilo, Linux loader. So the grub is the default bootloader of most Linux systems, and it's part of the GNU project. And these are the configuration files, names, and locations. These things they can ask. Okay. And you can do the configurations, do the changes to the configurations, and then you need to run update grub to transfer that to the operational configuration file. Okay. So you do the changes and transfer it to the actual file. Okay. That is how it is done. And of course, in your UCSC note, they have mentioned some configuration options, and they have already asked some questions on those options as well. Right. So these variables you can change values. Right. You can change the background image, some kernel parameters for the Linux, which one is your default OS. Then of course, if timeout happen, that will be loaded. Okay. So this is prevent the generation of recovery mode entries. It's enable or disable, and list of grub modules to be loaded as early as possible. So those are the load modules that will be automatically loaded. And grab timeout, that is how many seconds the menu will be displayed for the user to select the OS, right? If it is 10 seconds, after 10 seconds, this OS will be loaded. Whatever your grub default OS will be loaded after this seconds of timeout, or else whatever the user select will be loaded. Right? So if you want to do some configuration on the fly, so they have given some command line options also. Right? Boot, help, Linux, reboot, search, and USB. Okay. Right. So this is a difference between grub and lilo. So remember, grub is most of the time the default bootloader. So Grand Unified Bootloader. Lino is the Linux loader. Grub is uh, the more modern, flexible approach. Lilo is simple but less flexible approach. So that is why Grub is preferred. Grub dynamically load and modify its configuration at boot time. Lilo is more static configurations. Grub support more file systems. Lilo has limited support for file systems. Grub use stage-based booting. Lilo is more linear boot process. Grub support secure boot, whereas Lilo does not support secure boot. So that therefore Grub is more widely used and Lilo is less used because Lilo is simple but lacks some security and some other important features. Okay, so that is why Grub is preferred. Right. So that is Grub versus Lilo. Okay. Of course, we don't look at the boot manager because it's more Windows based, and we are not much interested in the boot process in Windows because system and network administrators mostly work with Linux machines. Okay. Right. So then the kernel initialization. So once the boot manager select the OS and load, what is the next step? Initialization of the kernel. Kernel is the core of the OS. Core of the OS. Right. So it initializes the CPU memory and device drivers, and it mounts init RAM-FS as a temporary root file system. Then it executes the /init from init MFS. Right? So from there, it prepares the environment to access the real root file system. So actually, this is your real root file system. Initially, it has a sort of a virtual root file system, virtual root or temporary root file system called init RAM-FS. Okay, sort of a RAM-based file system. And once those initializations are done, only it's switch to the real root file system and start the init method in SB system binaries. Okay. Right. What are the kernel startup options? For the Linux kernel startup options, again, there are two options, init or systemd. Again, one is the old approach, the other one is the new approach. So these are the Linux kernel options. All those are pretty much in your UCSC note or it's in your reference book. Because remember, examiner asked about 70% from the UCSC note, about 30% from the reference book. So therefore, I added some stuff from reference book into our note so that our note has, still you need to use the reference book, right? There's no alternative, but I have added content from both UCSC notes and reference book as much as possible so that it's easier for you. But it doesn't mean that just referring to this note is enough. Still, you need to go to the UCS reference book. And if you find anything interesting and possible in the exams, just add it to your note. Okay. Right. So what are the Linux kernel options? That is when you load the Linux kernel, you can turn on the debugging. Okay. And also you can specify what is your bash shell is. Okay. What is your shell is. Okay. And also you can specify what is your root devices and whether you want to boot in single user mode. So this is especially for debugging and recovery and so on. Okay. Because it reduce the number of services or the daemon starts. Okay. Right. So remember, if you want, you can specify the single user mode. Uh, so single user mode is a minimal set of file system is mounted. A minimum set of processors, daemons, and services are started, and a root shell is started on the console. Okay. So if you want to do this, you need to send -s single user parameter if you want to do this. So usually it is multi-user mode, where once you boot up, multiple users can log in. But if it is single user mode, only the root can log in. So that means the OS has essential features only. This is good for debugging, recovery, and so on. But usually when you boot up, it will be multi-user mode. So that is why you can have multiple users. Multiple users means even if you take two windows, two command terminals, so you can log in to one terminal using X user, other terminal using Y user. Or maybe those are different virtual machines. So maybe people remotely log into the system with different users. So another mode is, so these are the three modes: single user mode, multi-user mode, server mode. So in server mode, it is multi-user but no GUI. Remember, in servers, we don't run GUI. Why? GUI need more resources, right? So that means even though you have installed with GUI, you can make sure that boot up with only command line support. Or you can install only command line support. Actually, that is what actually happens, right? Rather than you install everything, because otherwise The disk space is also wasted. Okay, but this is another option. Yes, you install full, but you start in server mode. That means only command line is available. That means less resources are used by your OS. More resources are available for your web servers, database servers, and so on. Okay, right. So then it can call either init or systemd. Sometimes we use these two words interchangeably, but init is the older approach, systemd is the new approach. Okay, init or systemd. Okay. Uh, so when we say init these days, actually it loads systemd rather than init. Okay, but in older machines, it's actually init, not systemd. Okay, so this is the process with process ID 1, because this is the first process to run, or we call them the first daemon to run. That is why process ID is 1, right? What is that? Either init or systemd. These days it is mostly systemd. Okay. And it simply initialize the system login, networking, and mount points. So it basically prepare the system for use. And also it launches required services, right? So these are very important for exams. What your systemd or init does. And first of all, you must remember that that is your PID 1, process ID 1, the number one process, first process to run. PID 1, 2, 3, smaller values means earlier started processes. It's not priority, right? So usually PID 1, 2, 3, 4, these processes are system processes. Okay. And it launched the required services. We call them units. Units. So this is another thing they have already asked in the exams related to units. So units are something like the modules of your services. So you can configure which units to be loaded, which units to be not to loaded. You can say that after this unit is loaded, only that unit must be loaded, like dependency. Okay. Right. After doing those things, right, it will present you the CLI, command line login, no GUI login. Okay, if it is graphical target is set, you will get GUI login. Multi-user target is set, then you get command line login. So those things you can configure in the boot process. Okay. So remember we discussed about these daemons. So daemons are auto-started processes. Those are the high priority system processes. Okay, autonomously started, not by applications and so on. Right. So then we call it daemon. And most of these are, if it is a daemon, we call it daemon. Those are part of the kernel. Okay, OS kernel. Basically, those are OS specific processors. Most of the time, they are not configured and they don't require administrative attention because these are part of the boot up process. But we have a little bit of a control about these units, right? Especially their dependencies. So remember these system management daemons have low process IDs because process ID is low means those are started very early. Right? And these are mostly background processes. So usually we don't need to interact with these processes. Right? Again, init or system EMD is your number one process. Number one means the very first process to execute or very first daemon to execute. So bit of a comparison between process and daemon. Of course, daemon is a special type of a process. So daemons are pretty much background processors. But processors, when we say normal process, it's due to running of a program, like a Java process, Firefox. And processors are mostly run by a terminal because remember we talk about command line OSs, so then someone should have run it. So if someone has run it from a terminal, so then that process is bound to that terminal. But daemons are not bound to terminals because those are self-started things. These are some examples for processes like Firefox, say even Nano editor, right? ls command. So those are processes when someone run that command or run that application like Firefox. So that process is running. But daemons are pretty much background processes, system background processes, which always running and started at the very early stage of boot up. Anyway, we will be using these cron jobs. Cron jobs are scheduled jobs. Okay. So processes are manually started by users or any scripts. Scripts means we can write down scripts and run by us, or we can write down scripts and put it into a scheduled job. When the particular time date reach, it will be automatically executed by your cron uh, process. Okay, cron daemon. So processes are under user control. Daemons are not much under user control because those are pretty much part of the boot up process. So purpose of processes are perform a specific task when we launch that process and then close it. But daemons is something that keep providing the service for you because those are system services. So process will end when the task is completed or user stop it. But usually daemons keep running until you shut down your system because these are system processes. So this is a very good comparison between process and daemon. By the way, these are not mutually exclusive. Basically, daemon is a special type of a process. Okay. Right. So what are the responsibilities of all the init or new systemd? Setting these are all from your UCSC note. Setting the time zone, checking the disk with fscheck, fsck, mount the file system, remove any old files in the temp directory, right? Configure the net. So these are basically initialization. Configure packet filters for security if you have configured. Start up other daemons and network services. So this is the number one process or daemon. So then it can start up other daemons as well after doing this. So this is another very important slide for exams. What are the responsibilities of init and or new systemd? Okay. So remember now pretty much init is obsolete and more systemd is used. Okay. Right. So this is additional task of systemd. So of course systemd can do support all these things as well. Okay. But as I told you, systemd is more sophisticated. So therefore systemd have some added features, additional features other than these. Right. So these are very important slide. So systemd can provide dependency management. So that means if one process depends on the other, we can configure those things. Then systemd will make sure that those uh, depending processes are first started and then only uh, the other process is started because otherwise it won't work. That is number one, additional advanced feature of systemd compared to uh, init. Okay. Second one, support for concurrent startup processes. So concurrent means parallelly start. So when processes can be started, so systemd can parallelly start process. So when something can be start up parallel, obviously it become faster. So that is why these days loading OS is much faster. Still, I can remember about, of course, now the hardware and processor is also fast, but other than that, uh, especially SysTMD can start process parallel. So that means very quickly you get the responsive, uh, res your OS is now responding to your commands and so on. And also SysTMD provide more sophisticated approach for logging errors, events, and so on. So this is a very important thing. Dependency management, concurrent process execution, more comprehensive approach for logging. So those are some added features of SysTMD compared to the traditional init. Okay. So in order to do these things, the SysTMD has some uh, managers, or SysTMD has some components. So what are those? Network D. So remember, this is big guy is called SysEMD. System D. Okay, System D. Its subcomponents are network D, journal D, login D. Okay. Right. So remember we discussed about units. So units are sort of a sub-modules that SysTMD can manage. Okay, for you for the when for the users. Okay. So these units can be related to a device, mounts, and so on. Right. And units allow SysTMD to be flexible, fast, and parallel during boot up because it's modular. Right. So these units can specify, okay, this X unit depends on X and Y units. Sorry, Y and Z units. So that, and also since we have units, the SysTMD can start parallel some units rather than sequentially. Right? That will speed up, make it faster, make it flexible. Okay, the concept of unit. Right? So you can see units can be started in parallel based on dependencies. Right? Based on dependencies. Right. So these are some basic commands of units for units. Okay, which we can configure uh, for the customization of the boot up process. So these are, sorry, not customization. These are the commands that we can use to control units. Right. So list unit files will show all the installed units. Enable unit will enable a particular unit. You need to give the unit name. Disable unit will disable a particular unit during the boot up. Start unit can start a unit. Stop unit can stop a running unit. Restart unit, obviously restart a unit because units are sort of a independent submodules. Status unit will show the status of the current log entries. Kill pattern sends signals to unit matching patterns to stop it. And reboot is also a special unit which we even used last class to restart the machine. That is also a unit. Okay. So this is example of using these commands in a practical context. Okay. So this assume this is a particular service. Okay. Just assume this is a particular service. It can be even something like Firefox, Nano, or something like that. Okay. These are all assume that these are different uh, units. Okay. So therefore it can be anything, right? Right. So what does this says? It's check the status of this service. System control status. So this system control start will start this particular service. System control stop will stop this particular service. System control restart will restart this particular service. So even in Windows, you have the graphical user interface to restart, stop, start. Okay, so this is same as this services. So remember here also we have the services, right? So you can see some of these are running, some of these are stopped. For example, if I want to run a particular stop service, right, I can stop it, start it. Now, for example, this is stopped. I can right click and say start. Okay, now it is running. Right? And again, I can say stop it or restart. Okay, now it stopped. These things are in Linux. We can do it in command line. System control start service name. System control stop service name. System control restart service name. System control status service name to show the status of whether it's running, stopped, and enable a system service. System control enable this. So that means at boot up, enable it or disable it. Don't run it at the boot up. System control disable your service name. Okay. And this is if you want to see all the units. System control list units hyphen type equal service. List all the units or services. And these are the categories of units. Right? Categories of units. Service type units, target type unit, socket type unit, devices, mount, and timer. So I think this is I took it from your reference book because examiner has kept asking questions from reference book as well. Okay. So service type units, target, they have different file extensions also. Socket, uh, device, mount, and timer. Okay, so timer is pretty much scheduled task. We will be doing prawn jobs. Then you must know that, okay, this is, uh, we are using a particular unit called timer when we run cron jobs. Okay, cron jobs. Okay. Of course, we can mount the file system. So then we use the unit called mount. And these are the possible status of a particular unit. What are those? These are all possible exam questions. Okay. So bad, that means it has some issues. Disable, that means it won't auto start up at boot up. It's disabled, configured as disabled. Enable means it will auto start in the boot up because we have enable auto. We can change this. Right? Indirect means disable but has peers in also closer that may be enabled. So that is means it's by default disabled, but if there are some other units that need this service, you need to start. Otherwise, yes, it's disabled. Okay. So linked is more related to creating link files and so on. Okay. Right. Remember, units support dependency management. So that means we can configure that, say, unit X depends on unit Y. So then it will make sure that first unit Y start, unit Y is started, and then only unit X is started. Okay. So we can order, group, and also we can control the timing. Timing means which must run before the other. We can group related units together. Right. So remember, unit supports dependency management. You can say before running ESET, make sure you run X and Y. Okay. So these are the unit dependency management directives. Say requires equal. So what are the units requires to be run? Wants. So this is called hard dependency. It's required. It's a must. Wants is soft dependency. Okay. So that means start the listed unit if possible. Failure doesn't stop the unit. Here, if you can't run those under requires, your current unit won't be run because it's a hard dependency. This is soft dependent. So this soft dependency means it will try to load these units. If it is not, or if some of the units fail, still it will try to load this, your main one. But here it will never run your main unit or current unit unless you have those dependencies loaded. So this is how you configure dependencies. Say before. So before this unit, which units must be run? So you can list down which units to be run before this run. And after means after this is run, what are your suggested units to be executed? And conflicts means asking the operating systems that please prevent this kind of dependencies, right? So we can say that don't get into this kind of sequences. Okay. And this is an example of a unit file with configurations. Remember, every unit has a unit configuration file, right? So this is an example for NGINX service. So it has a description. So then it says after these units must be loaded. Right? Type is forking, then PID file, start prerequisite. This is the starting point, and so on. Okay. And you can see wanted by. That means hard dependencies, right? Right. So remember these are special units. Halt, reboot, shutdown. So those are also units, but some special units. Okay. Special units. So halt is pretty much like shutdown. Okay. Uh, Required for shut down the system. Then what is the difference between halt and reboot? Reboot is essentially identical to halt, but it forces the machine to reboot instead of halting. Okay. So reboot will restart, whereas halt will shut down. Okay, shut down. So then we have shutdown. So then what is the difference between halt and shutdown? These are the possible questions. Okay. So your shutdown will schedule your shutdown. Right? So it schedule your shutdown and notify the other users and so on. Okay. But halt will immediately shut down. Okay. But reboot is restarting. Right. Tactics for non-booting systems. So non-booting systems means you have errors. Machine is not getting boot up. There was a past paper question on this also. And this is directly from your UCSC note. Of course, UCSC note is copied from the reference book. Okay, that means if it is in UCSC note, mostly it is in both UCSC note and reference book, right? Or else it's in reference book but not in UCSC. Sometimes the examiner is looking for things which are not in UCSC note but in reference book. Okay, when he or she is creating your questions, right? If your system is not getting boot up, that means there is a technical problem, right? Hardware problem or whatever. Right. So these are some basic approaches to overcome the problems, right? Possibilities. Maybe one possibility is don't debug, just restore the system to non-good state. That means if you have a restore point, because now this is not getting boot up, if you have a restore point, just restore that restore point. Simply, issue is resolved. But maybe you need to reconfigure according to your current requirement because we have set it to a restore point. Second option is bring the system up just enough to run a shell and then debug and try to figure out. So that means you somehow you want to start up the OS with minimal support because normal startup is not happening. So you just like single boot, single user. Sorry, not single boot, single user mode. So you just ask the minimum services to be run and then you try to figure out what is the issue is because now at least you can log into the system. Third option is boot a separate system image. Okay. So that means you just use your hard disk or SSD, right? But you boot a separate image and you connect to this one and maybe you can see whether you can uh, restore it or you can fix it or maybe simply you want to copy essential files because you can't run that. Okay. So these are the three options given in your UCSC note and reference book. That means simply restore to a known good state, bring the system with minimum functionalities, and then see whether you can troubleshoot and fix it, or boot a separate system image. That means you have a separate OS running, but you access your file disk and see whether you can fix any issues. So those are the three options. Okay. Right. So remember, kernel is the core of the OS. Right. So the Linux kernel is the common component for all these OSs like Red Hat Linux, Fedora, and so on. Okay. So then drivers are pretty much sort of a firmware that drive or run your hardware, like network drivers, even processor has drivers, and so on. So mostly drivers are firmware. Okay. Right. So that is I just because I added a lot of new content to the node going through your reference book also. But again, don't skip reading the reference book thinking that, okay, our note, Aurora note has all the things. No, right? I can't do right because your reference book has about, I think, 50 odd pages, right? How can I take all 50 of pages to this? I just took what I think important, what I think possible past areas for the examiner to create new questions. But you also need to go through and add your own content that you think possible exam questions in the future. Okay. Right. So we'll take a small break. After the break, we'll move on to our today's topic. Uh, that is Linux host management. Okay. Linux host management. So now it is, let's say 8. We'll start at 8:15. Right. 8:15. Okay, so let's continue. Right, so now we move on to our third topic, uh, Linux host management. This is third topic, right? Yeah, host management. So then we have three more topics, okay? Small syllabus, but you need to be very serious about each and every topic. Right, so this is all about the basic familiarity with the basic operations in Linux, right? Rather than advanced things like network management and so on. The basic functionalities like creating users, creating groups, creating a file, right, and giving access, uh, and also installing, uninstalling software. So the basic operations, okay? So part of this you have already done in semester one under free and open source software. Uh, but anyway, we'll start from the beginning. Okay, right. So these are the basics. Command line work with Linux, and also uh, these are the usages: user management, file and folder or directory management, program management, security management. Of course, network configuration and automating the system tasks are done in our next subtopics, next topics actually. Right. Right. So I will be using my Linux or Ubuntu installed using Oracle VirtualBox. Okay. Let me start it. Okay. So sometimes I run out of system resources in case of a crash. Just be patient. I will again join the session, right? I hope it won't happen today. Make Let me close all the unnecessary applications, okay? So that I have enough resources. Right, so I log in. So last time I explained how to install. Anyway, you have done it in semester one also. So this is a practical subject. You must do this in practical manner. Okay. Right. So you can get a terminal. If terminal is not hyperlink in the old shortcuts, you can click on here and get the dash, and then uh, search for terminal. Okay. Or say terminal and click on. You can get, if you want, you can get multiple terminals also, and you can even log in uh, using different users for different terminals. So that is also possible. Okay. That means you can have different command lines for different users. Okay. Uh, right. So the basic commands are, I think I did not explain much about that. Anyway, you have done these things in semester one also. So the first one is uh, print working directory, PWD. When you log in multi-mode uh, environment, that is the default login. Uh, so there's a remember the Linux file system is always starting with root. Root. There's nothing called C drive, D drive, and so on. So you start with root. Okay, let me close this. Right. So it starts with root, and under root you have home, and of course there are some other folders like bin and so on. But under home, every user has a folder name. Okay. Under home, for example, if I have a user called Nalaka, if I have created a user account called Nimal, then slash home Nimal and so on. Because I log in as the user called Nalaka, this is my default home directory, home/home/slash Nalaka. And this is where you have the full control. So therefore, this is a good place to play around, because if you go to other folders, those are more related to system processors and so on. And most of the time you don't have access. Of course, you can get the access. But this is where you get the full access. This folder and any subfolder you create under your user home. Okay. Right. So at any time, if you want to check where are you, just type pwd, print working directory. And if you want to check what is your current user name, because you can log into different terminals using different users also. Sometimes you might forget which user you are logging to that particular terminal. So that is, you can use who am I? Who am I? Right. So it shows what is your current username for this session. Right. So this is current directory. This is current user. And of course, you must be able to uh, navigate through your Explorer or your file system. So currently, my current folder is /home/Naraka. If you want to see what are the content of your current folder, type ls list. So you can see it has some files and some folders. Blue color means folders in Ubuntu. A white color is files. Okay. I have created some folders for different, especially semester one classes. Okay. I think this is semester five folder for last year batch. Right. So that is your current content of the current folder. And if you want to go one level up, you just type cd dot dot. So that means one level up. Of course, one level up from current folder is home. Okay. Now, if I type print working directory, yes, I'm in home. And what are the content? So I can see only Nalaka folder. Okay. Uh, anyway, I think it's only have Nalaka folder because I have created only one user. Okay. Right. So then if I want to go one step up again, now I'm in the home folder. I will end up in root. Okay. Root. Sorry, ls space. Sorry, not ls. Uh, cd. cd dot dot. Sorry, not lscd. Sorry, it's my mistake. cd dot dot. Right now I am in the root. If I type print working directory, I'm in the root. So there's nothing beyond that. All your files and folders start from root. Right. If you want to check what are the content, you can type ls. Right. You can see bin folder is there, lib folder is there, lib32, lib64, right? Lib32, then sbin is there, system binary, a swap folder is there, tmp is there, and so on. Okay. And these are some files. These are some files. And of course, and no, sorry, there's a home folder also. Boot folder is also there. CD-ROM folder is there, dev folder is there, etc folder is there. Remember, we came from home, okay? And some mount folders are there. Root folder is there, okay? So there is a that usually you have access. Only the root has access, okay? So those are some common folders. Especially you need to remember bin, sbin, okay? Lib and lib32, lib64, and so on. And also the boot folder. Remember, this is where your bootstrap related things files are. Another important one is dev. Another one is etc. Okay. Mount, where you have, if you have mount any disk and so on. Okay. Uh, and Y is where you have your variable things like log files and so on. Wow. Okay. Right. So if you want to directly go into the home folder, you can type cd title. Title. This is not a hyphen. This title in your special characters. That means you directly go to the your use home. My use home is /home/Nalaka. Directly go in there. Okay. So now if I type print work in directory, right. If you want to directly go to the root, just type cd/. So then you directly go. You are in the root. Okay. Or else, of course, you can just say cd home, then cd, in my case, Nalaka. Or you can say, I get back to the root, you can simply say cd home/null. Likewise, you have the flexibility. Now I am in Nalaka folder in my case. Okay. Right. So next, now I am in Nalaka folder. I'll create a folder. How to create a folder? mkdir. Okay. First, I will show you how to create a file. There are different ways you can create a file. The easiest one is touch. A touch. I will call this uh, F1. In Linux, it is not a must to have a extension for your file. If you want, you can have extension, but it's not a must. Okay, so I'll say F1. Now, if I type ls, so there's a file called F1. Okay. Already there's a file called F2 tx2, but I will create another file called F2. Right? Touch F2. Right? So now I have a F1 file, F2 file, and there's a file called f2.txt. So those are two different files. Okay. And if you want to create a folder, so already there's a folder called sem5. I will just call sem525. Okay. mkdir sem525. Okay. Now if I type ls, there should be a folder called sem525. Yes. So let's go into that folder. cd. If you type the first few letters and tab, you will see what are the possibilities, right? So many possibilities. Say, if I press sem5 to 25, right? So now if I type ls, nothing will be there because that is empty folder. Remember, now I am in the sem525. Right. I will touch few files. Say touch, say F1. If you want to create multiple files, you can have something like F1, F2, say F3.txt. Say I want to create a file with extension also. Now straight away I created three files. If I type ls, you can see F1 file, F2 file, F3 txt file. And again, I will create another subfolder here, mkdir. I'll call it sub, okay, or sub1. Now this is not a file because I use mkdir. If I type ls, you can see that my files are there, folder or directory is there. But if you need more details, you can type ls minus l, long, right? List in long manner. So these are the file security. This dash means it's a file. If it is a folder, you have D. So obviously sub1 is a folder, so therefore you have the D. These have dash because dash means it's a file. Dash means it's a file. So then this is the use owner of the file, in my case Nalaka, because I just touch these files and folders. And this is the group, file group. File group means the users group. So usually when you create a new user, by default, a group is also created with the same name. So then if for example, if you create a file, user called foo, you create a user called foo and group called foo. And the foo user belong to group called foo. Or else when you create the user, you can specify what is the foo, group. So then that user will be belong to that particular group. Group can have multiple users. So this is the user of the file. This is the group of the belong in that file. Then of course creation time and so on. Okay. Uh, we will look at more of these things. So these are the security parameters. So this is basically user, read, write, no execute. For group, read, write, no execute. Next tree. The last tree is for others. That means not the user, not anyone from the same group. For others, that means there's a particular user which is not in my group. So then it's other. Right? So for others, it is only read, cannot write, cannot execute. Read means you can read the value use data content using editor like Nano. Write means you can modify and save. Execute means you can run it like a bat file, SH file. In Linux, of course, we call it SH files. You can execute that. Okay. You can see because I created all these files, it has almost identical access. Okay, but we can change this at any time. We can change. We can make it more relaxed or more strict to access these files. Okay. Right. So we discussed about who am I, PWD, and of course, if you want, you can customize your font sizes and so on as well. Uh, and at any time, if you want to clear your screen, just type clear. Yeah. So that clear up your window. Your all commands are now not available because you cleared it. Right? For example, if I type ls, all commands are still available. Sorry, you can see clear ls mkdir. I thought all commands are not there. All commands are there, right? From starting of the terminal. Okay. So how to get the all commands? You use up arrow or down arrow key. Okay. And if you want to type bit of and get the suggestions, you type partially and say use tab. Right. You can see so many possibilities, mkdir and so on. Okay. But if it is very specific, and now it will basically fill it, fill it. Okay. Right. So those are basic skills. And the other thing is there are some commands that you can't run because by default you don't have get the admin power when you create a user account at uh, installation time. But there's a concept called temporarily getting the admin rights. So remember in Windows also we have concept called run as admin, right? So therefore, especially in Ubuntu families, you can use sudo in front of the command. That means if you can't do something, saying you get a message saying you don't have the privilege, your next thing is you just type the same command with sudo. For example, if LSC is not giving you anything, you can type sudo ls. Of course, for ls, you don't need to worry about that bit, right? Sudo is not required, but this is something you can do. Okay. And of course, especially software installation and so on, we must use sudo. Okay. Of course, for ls, you don't need sudo, but this is how you do it. Sudo ls. So then it asks what is the password, not the password of the sudo, what is your password? Okay, so my password I will type, and then only the command is executed, because now it is something like run as a administrator. Okay, so this is the basic file structure. You have the root, then you have the uh, home. Under home, if your current login is John folder and all your subfolders and so on. So then parallelly you have the var variable files where log files and so on will be there. Under USR you have the bin lib etc is there parallelly. Some media, those are mounted media and so on. Just very simple, okay? Right. So other thing is you must be able to use editors and viewers. Editors to edit and view both. View, that means you don't edit, just view the content like Notepad. But Notepad, of course, you can edit also. Okay. Right. So these are the text editors like VI, Vim, Nano. So Vim is the advanced version of VI. Nano is the most user-friendly text editor, command line text editor. These are command line text editors. Okay. So whatever we do from this point onwards, we must be able to do only with command line also. Of course, we have the graphical user interface, but I will not be using graphical user interface because your syllabus is how to work in server mode. Server mode means command line only. Okay. Right. So first we want to add some text. So therefore, I will use Nano. Okay. Nano is the easiest to use. So remember, I have a file called F1. Nothing is written yet. Okay. I will edit it using Nano. Nano is a uh, text editor, a very popular text editor. Usually, it is already installed in your machine. If not, in your OS, if not, you need to install it. But usually, it is already installed. Okay. There are different ways you can install Nano. We will discuss that when we move on to software installation. But usually Nano should be built-in available in your OS. Okay. So I will type Nano. I am in the current folder. That is Nalaka. Sorry, same 525. There's a file called F1. I will say Nano F1. So this is my editor. Okay. It's a editor. So then you can type, say, I will say my first line, my second line. I just had 3 lines. My third line. Right. So then you can save. You can see the shortcuts here. Write out means uh, save. Right. That means Control O. I will now use Control O. And it asks you, do you want to override the F1? I will say yes. That means enter. Now I have saved it. Now I can quit. How to quit? Control X. Right. Now if I type ls, ls minus L, remember we edit F1 file. Right? F1 file is now about 44 kilobytes. These are empty files. And if you want, you can use BI also. Uh, and if you want to just weave it, you can use cat. Cat. Say I want to weave F1. You can see. But this is not editor. Cat is a weaver, command line weaver. It just you can just view the contents, but you can't edit. Right? Cat and file name. Usually this is also built-in available in your OS. You don't need to install, right? Cat command, nano command. For cat tool, nano tool. So cat is just reading, nano VIM are for editing. Editing and reading both. Okay. Right. So let's use a bit of VIM command also, Vim. That is also basic editor. I don't know whether VIM is there, otherwise I will use Vim F1. So this is again, I can edit now because this is also edited, but not as sophisticated as Nano. I will add one more line. Okay. To edit, you need to get the focus. How to get the focus? If you want to edit, uh, how to get the edit? There's a command. Okay, there's a command. Where is that? All right, I've got it. Okay. So now I'll type, say, my fourth line. All right, now if you want to save, uh, these are a little bit difficult to remember commands, shortcuts. If you want to save, you can say colon W, then quit colon Q. Or you can combine colon WQ, that means write and quit. Right? Or you can just type colon next, that is a shortcut for write or save and quit. Right? So if you want to quit without saving in Vim, colon Q exclamation. Okay. So I want to save, therefore I'll type colon W because I add some code, right? Escape, colon, first you need to use escape character, colon W and enter. It's now saved. Now I want to quit, right? Colon Q. So you're back in your terminal. Okay. Now if I type cat, there should be another line. Yes. Fourth line is that cat is the weaver. Okay. That is how you use Vim. And this is how you use Nano. Of course, Nano, you don't need to memorize also because you can see the shortcuts. Anyway, in the exams, they can ask. Right. Right. So these are some important directories. I already explained you. Slash is your root. Slash home is where each and every user's home directories. Boot directory keep the Linux kernel and bootloaders. etc contains configuration files. Bin and user bin is something like our program files. It has the essential program files. Lib contains shared libraries. So that means probably those files are shared among different processors and OS and so on. And temp is keeping the temporary files. Sometimes even log files are considered temporary files. Okay. Some more folders like slash root, that is super users home directory, slash dev, it containing some drivers and so on. Slash proc, it's a virtual directory for running processes. Slash media mount to mount hard disk, SSD, and so on. And slash var, again keeping log files and so on. Okay. Right. Any questions? Right. So some configuration files. Remember, etc folder is important folder. It contains a lot of configuration files. So these things they have asked in the exams also, right? etc. What is the use of etc folder? So it contains most of the configuration files. Okay. Uh, and these are some important configuration files. etc folder has a passwd, right? It contains the password file of each users, but we can't read other users' contents because mostly these are encrypted. Then etc fs tab contains table of devices that are mounted. etc host has the host names and IP address mapping for your internal DNS activities. etc initd, remember we discussed about initd, it contains mostly the uh, boot up related stuff, okay, configurations. Right, so the next thing is user management and group management. So remember when we install our OS, uh, we created a one user, right? So of course the super user is there root, but usually you don't get the access login details of the root user unless you are a system administrator, okay? But you should be able to create other users. Of course, if you have that privilege of creating users, usually system administrators have that privilege or they can get that privilege. So if you have that access or privilege, you can create users and groups. Most of the time in Ubuntu, you get that access, but if you have not login using that user, you will not be able to do it. Okay. And the other thing is you can type sudo. Maybe you have that access through admin or the super user. Okay. Right. So this is how you create a new group. Group add the group name. So, okay, let's do it as a practical thing. Let's create a group. Okay. So group add GR OUPAD group 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 add. I'll say there's a group called foo. Okay. So permission denied means I need to use with sudo. Okay. Sudo. Sorry, not sudo. Uh, yeah, with sudo. Okay. Sudo. Sudo. My command is still group add, and this is the group name. Okay. No message means success. So that means there's a group called uh, foo now. Okay. Foo. Now let's see, I can create a user also. Right, so this is how you delete a group. Group del your group name so that you can try out. Okay. Make sure you use sudo so that you have the admin privilege. Right. So there are different type of users. The super user is the root user, admin user. So by default in Ubuntu, the super user is disabled. That is why you can use sudo and get that temporarily get that super user privilege. Okay, but other usually it's a normal user. But anyway, any user can get the super user privilege if you have given that level of access. Okay, sometimes we can configure so that you don't get the super user features. Okay, that means you can't use sudo. Right, I already explained how to create a group. That is group pad. Now we have a group called foo. So let's add a user now. How to do that? Use add and username. If you just give use add and username, say you say use add u1, then there will be a user called u1 and group called u1. So group will be automatically created. But if you have already created a group and you want to bind this user to that group, you must say use add minus g your preferred group name and username. So then there will be user created with this name, and that user will be added to this particular group. Okay. But if you just use this, a new group is created. Okay, let's use this approach first. So I will use sudo group, right? Group at gr, sorry, use add, not group at. I will call this user bar. Okay, right. I'll call this user usr1. That means this user is uh, added to the group called user1, and username is also user1, group name is also user1. So this user will belong to the group called the same name, that is user1. Okay, user1 already exists. I will call this user2. Right, so now I have user2. User2's group is user2, but user1, sorry, there's a group called foo. uh, I will add a now new user called user 3, but I will add that user 3 to the foo group. How to do that? Right? Use sudo user add minus g group and the username. Okay. So use add minus g. I will add it to the foo group and your username. That is user 3. Okay. Okay, USR3. Right. So now I have created a user called user 3 and I have added that to the group called foo. Okay. Group called foo. So that is how you add users. Okay. Right. So then you need to set the password for the user. Otherwise, you or anyone will not be able to log in. Okay. So once you set the password only, someone can log in using that username and for the password. Okay. So I'll set the password for say user1, USR1, set pass. So we need to use with sudo as well. Sorry, not set pass. Sudo pass wd. Pass wd. So then you need to tell what it which user to which user. Uh, so in my case, username is let's set it to user 3. USR3. Now it asks the password. I will give the password as USR3 also, just to make it convenience. So now it says it's a bad password. It needs at least 8 characters. Okay. I will say USR 3, 4, 5, 6, 7, 8, right, 9. It says bad password, but anyway, I can continue, right? Yes, I'll continue then. Okay. Right. I will enter the password as same as username. USR3. Yeah, it says bad password, but I will stick with my password. USR3. That means username is USR3. Password is also USR3. Okay. Uh, so if I want, I can take another terminal. Sorry, not this. I am getting the same terminal. I will say new window. I think the same terminal I have it. Do we have tabs? No, right? No tabs. Okay, so let's take another terminal then. I'll say new window. Right. By default, it is also login as Nalaka because this is my main login. If I type who am I, now I can change to user 3 because I have set the password for user 3 also, right? Right. My username is USR3. I type switch user USR3 and it asks password. I will say USR3 because I set the password as USR3. Now, this terminal, the user is USR3. Shall we check it? That is, who am I? This terminal is USR3. This terminal is Nalaka. Say, who am I? You can see that is called multi-user. Different user sessions in the same machine. Okay. Right. So now you know how to create a user, how to create a group, and how to add that user to that group, or you create a user with a group of the same name as well. Okay. Right. So remember, by default, the users cannot use sudo. For example, let's see, uh, this is my main user. I can type sudo. Say sudo, say ls. Of course, I don't need sudo for ls, but I can use sudo. Now let's see whether the new user that I have created can use sudo. Where is that window? Right. So let's see whether I can type sudo ls. Password is USR3. You can see that USR3 is not in the sudo's file. So the incident will be reported. So that is, don't worry. You can see that by default, when you create a user, that user cannot use sudo, or that user cannot temporarily assign admin power. Okay. So how do you give admin or the sudo power to a particular user that you have created? So this is how you do it. Sudo user mod minus a capital G sudo, and this is your username. So then only that user can use sudo. Or then we say that that user is added to the sudo's group. Okay, so let's give the sudo access to this guy. Only Nalak user can do it because Nalak user has the admin power. Okay. Where is my right? So how to give sudo access? So I need to say that also you need to do using sudo, right? Sudo user mod user mod minus a capital G hyphen a capital G. So I think simple capital matter there. So then sudo to USR3 USR3. Now the sudo access is given to user USR3. Okay. Now if you take the other terminal, still I don't think that this user can. Let's see whether we need to log off and log in. Okay. So let's see. Sudo ls. Password is USR3. Right. So USR3. USR3. No, I will take a new terminal and see because I change it only now. Okay, so this guy has login before doing that. So let's take a new terminal. Yeah, close terminal. Let's take a new terminal, new window. I will SU USR3 USR3. Okay, now let's see whether we can remember who am I at USR3. Now let's see whether I can use sudo ls password USR3. Now I can use, of course, you don't need sudo to ls, but you can see that now you can do it because from the other terminal, I added, right, I allow sudo access to the uh, USR3. Okay, USR3. So these are very important. Uh, okay. And of course, if you want to delete a particular user like USR3, you can use user del minus R username. Again, use with sudo. Otherwise, you will not be able to do it. Right. So if you want to find all the details about all the users, you can type get ent pass wd. I will use this one. Use end sorry, get ent pass wd. I will use sudo also. Get ent pass wd. And the username. If you want the specific user, USR3. And you can see the details about USR3. And this is the user home uh, and so on. Okay. But if you need everything, all the users just do not give the username. So that shows all the users. Okay. You can see user 1, user 2, user 3. Nalak user. Okay, so this is a home directory. And this your bash is my default shell. But for these guys, the default shell is sh. Okay, and so on. Okay. And X means the password actually, right? Because you can't see the password. Right? Username, password. Password is given as X. Right? You can list the groups and so on, right? I'm not going to do each and everything. Okay. Right. Access control and beyond that, we will do next time, and next class we can finish this, right? Because there are a bit of theory behind that, uh, including file access levels, user level access, group level access, others, and so on. Okay. A lot of technical stuff are there. So therefore, we'll do those things in the next class. Okay. And we stop at this point, right? Thank you.